This is section 6.2. We will have a quiz on section 6.1 and 6.2 on Friday, so please pay attention. This is straight from the book, page 393. The inverse relation is the set of ordered pairs that is obtained by exchanging the coordinates of each ordered pair. The domain of a relation becomes the range of its inverse, and the range of a relation becomes the domain of its inverse. What the heck does that mean? It simply means this. To find the inverse, all you got to do is switch the x and the y values. Okay? So, if you understand that, go ahead and find the inverse of A. What's the inverse of these coordinates? Could anybody tell me out loud what's the inverse of the first coordinate? 1, 5. 6, 2. 7, 5. That's the inverse, right? Understand? Okay, we're good. Let's have a quiz. I'm just kidding. So, of course, there's a little more to it. I have some, exercises I want you to do right here. I want you to plot both the original coordinates and the inverse coordinates right here on this graph. So let's do that. Let's plot the top ones in blue. So here's 5, 1. Let's go to 5, 1. 1, 2, 4, 5, 1. It's right there. Let's go to 6, 2. No, I'm sorry, 2, 6. 2, 6. Now let's plot 5, 7. 5, 7. Okay, so now let's plot the inverse coordinates, which is 1, 5. 1, 5. Let's plot 6, 2. And let's plot 7, 5. Does anybody notice anything about the coordinate and its inverse? Looks rotated. Okay. You know what? We'll get a better understanding if we do the next exercise. The next one says right here, number 2, plot the triangle with the coordinates -7, -5, -7, 0, and -3, 0. So let's graph a triangle right here. I'm going to use green dots. -7, -5, -7, 0, and also -3, 0. I'm actually going to draw my triangle through those green dots. And the next step is to plot the inverse of that triangle. So could somebody give me the first coordinate of the inverse of that red triangle? -5, -7. What else? 0, -7, which is down here. And then? 0, 0, -3, which is right here. So we have this triangle right there. How about now? Are you guys able to tell me, describe what the visual difference is?
Yes.
What happens?
It's basically just like a 180.
It's like a 180. Like you're talking about like a reflection?
Yeah.
Perfect. It's a reflection. But what is it reflected over? Like, is it reflected over the x-axis?
No.
Is it reflected over the y-axis?
No. It's reflected over x equals y.
Over x equals y. Or over y equals x, right? So if you guys aren't too familiar with that, the line y equals x, if you think of it in terms of y equals mx plus b, that would cross at 0, and you go up 1 over 1, up 1 over 1, up 1 over 1, right? So you end up with this line right here. Or another way of thinking of this line, y equals x, your y values have to be equal to your x values. So on a coordinate, if your x value is 1, your y value has to be 1. So 1, 1, 2, 2, 3, 3, right? -1, -1, -2, -2. So here is your y equals x, your y equals x line. And what I wanted you to realize with this couple of steps, this exercise that we just did, I wanted you to realize that when you take the inverse of a coordinate, it gets reflected over this line y equals x. I mean, technically, when I tell you to find the inverse of any coordinate, what are we doing? We're switching x and y, right? What would that imply? That means that your y's are equal to your x's for you to be able to switch them, right? So it's really just a reflection over the y equals x line. I think that's pretty cool. So down here on number 4, what can you state about the visual difference when you graph anything and its inverse? You would say it gets reflected over the y equals x line. All right, so hopefully everybody wrote that down. Now let's talk about the notation of an inverse of a function. So this little power of -1, it's really not the power of -1. It's just the notation that tells you to find the inverse of f of x. So if I give you a function f of x, instead of me giving you the written instructions, find the inverse of f of x, I could just give you this notation. This notation, what it means is to find the inverse of f of x. Okay, so just keep that in mind, that this notation is really saying find the inverse of f of x. Okay, so how do we find the inverse of a function f of x? Now, to find the inverse of a function of f of x, or using the appropriate notation, I could have said this instead of this whole sentence right here, or whole phrase. To find the inverse of f of x, all you have to do is switch your x with your y, right? Since it got reflected over the x-axis, not over the x-axis, since it got reflected over the y equals x line, that's why we're switching x and y. So switch x and y and then solve for y. That'll give you the inverse function of whatever you have. So right here's an example. Find f of -1, or not of, it says find the inverse of x, f of x. This really means find the inverse of f of x. And here is f of x. Let's find the inverse. Well, we begin by switching x and y. Where's my y at? The f of x is y, right? Okay, so let's first put a big y right there. Y equals 3/5 x instead of f of x equals 3/5 x. And how do we actually find the inverse? What does it say? Switch the x with the y. Switch. You just magically switch them. So what do we have? We have x equals 3/5 y. So we magically switched x and y, but what else do you do besides switching x and y? Solve for y. Okay, so I need to solve for y. I need to get rid of this fraction 3/5. Multiply by 5. What you do to one side, do to the other side. You'll have a 5x equals 3y. Final step will be what? Divide by 3, divide by 3. So you're going to have y equals 5/3 x. So this is your inverse function of the original f of x. So if I wanted to state that's my inverse function, the appropriate notation will be f with that little -1 equaling 5/3 x. So you're going to have to find the inverse of any function on Friday's quiz. I'm going to give you a function. You're going to switch x and y and then solve for y. How do you find the inverse? You switch x and y and then solve for y. So let's practice with this guy right here. They want us to find the inverse of g of x, right? This little -1 is really not the power of -1. This is the notation saying find the inverse of g of x. So how do I find the inverse of g of x? Instead of g of x, what is that really?
Y.
It's really y. And how do I find the inverse? Switch the x and the y. So x is right here instead of y, and 3, and a y is right here instead of x, minus 2. Okay, so I switch it, and then I solve for y. Okay, so how do I do that? Add 2, add 2. Can't really add x plus 2, so let's just rewrite it. X plus 2 equals 3y. What's my final step going to be to get y by itself? Divide by 3. Divide the whole thing by 3. So there's your answer. Y equals x plus 2 divided by 3. And let's write it with the appropriate inverse notation. G with the -1 of x, that really means the inverse of g of x equals x plus 2 over 3. This is the correct answer with the correct notation. Now, on your midterm exam or final exam, if for some reason you don't see that identical answer right there on your multiple choice, they might have taken the 3 and split it to the x and to the 2. So here's another perfectly acceptable answer. The inverse of g of x equals 1/3 with the x plus 2/3. Cool? So on this next section, actually, let's delete this top part. I messed up. Let's just scratch this top part out. And let's begin by reading. We could just jump to the key concept, actually. If you take one function, g of x, and plug it into your f of x function, and your answer is nothing but x, and then if you go the other way around, plug in your f of x into the g of x function, and your answer is also nothing but x, then f of x and g of x are inverse functions. I know it's kind of weird, but it's pretty simple. You see, the word inverse itself kind of means to undo something, right? So like if I have 3 times 2, and then I do the inverse of times 2, which is divided by 2, the times 2 and the divided by 2 cancel itself out, right? So right here, when you take a function and you plug it into the other one, if they're inverses of each other, everything cancels out except for x. And that's a way to determine whether the two functions are inverse functions. So here's the instructions. Determine whether the functions are inverses. Write yes or no. So you could, if you wanted to, call this y, that x, switch them, solve for y, and see if you get this guy. Then you call this y, call this x, switch it, solve for y, and see if you get this guy. Or using the above key concept right here, all you do is plug one of them into the other and make sure that the answer ends up being x. And then plug in the second one into the first one and make sure that the answer ends up being x. Okay, so it's pretty easy to understand, and the more you practice it, the easier it gets, obviously. So if I were to plug in my g of x into my f of x, in other words, f of g of x, if this answer equals x, then so far it is a function, an inverse, or they are inverse functions. So let's do that. If my f of x function is 2x minus 8, I'm going to put 2 parentheses minus 8. And what am I going to plug in inside my parenthesis? Ariana, what am I going to plug in inside of this parenthesis right here? One half x plus 4. Braulio, you got that? Yeah. Okay, so you're going to plug in 1/2 x plus 4 right in there. Let's do that. 1/2 x plus 4. So I need to multiply that 2. The 2 times 1/2. What's 2 times half?
1.
It's just 1, and you end up with just an x, huh? And then when you go 2 times 4, what's 2 times 4? Positive 8. After you've distributed, you still have this minus 8 at the very end, and check out what happens. Cancels out, your answer is just x. Beautiful. So far, f of x and g of x, they are inverse functions, but it has to work for both. All right, so we plugged in the g of x into the f of x. We now need to plug in the f of x into the g of x. And it also has to give me the same answer, just x. If it gives me 2x, it's not going to work. If it gives me 1, it's not going to work. Right? It has to give me the answer, just x. So let's show that we're plugging in f of x into g of x. So my g of x function is really 1/2 x plus 4. If this said g of 5, I'd plug in a 5 right here. But it doesn't say 5, it says f of x. So what am I plugging in right here?
2x minus 8.
There you go, 2x minus 8. And when we distribute 1/2 times 2x, that's just x. And 1/2 times negative 8, that's just negative 4. And of course we have the plus 4 out here. And again, they cancel. you get the nice answer x. What does this mean? You checked it, you would say, yes, these guys are inverse functions of each other. Now, if you would have gotten x here and 2x over here, nope, they're not inverse functions. It has to work for both. It has to be an x and just an x. So here's our homework. And 1 and 3, it's as easy as switching x and y. So this is 3, 0. This is 2, 4. This is negative 6, positive 5. Boom, I found the inverse. You could do number 3 and you're good. And we're skipping all the way to 7 and 9. I'm not going to do 7 or 9. I'm just going to do 8, and you guys should be able to catch on and do 7 and 9 on your own. So we need to graph the function and its inverse. So how the heck would we graph g of x equals 3 plus x? Well, g of x is really the same thing as y. And instead of saying 3 plus x, let's say x plus 3. That way it looks like it's in slope-intercept form from Algebra 1. Remember, it crosses at 3, and my slope is up 1 over 1. You guys remember that? Okay, if you don't, you guys need to go back to Algebra 1. Okay, so it crosses at 3. Let's all put a dot at 3. 1, 2, 3 right here. It's your y-intercept. And your slope is up 1 over 1. I hope you guys remember this. Up 1 over 1, up 1 over 1. And you could use that pattern backwards. So here's your line. Yay? That is your line that's called g of x. Now they want us to also graph the inverse of g of x. We already know that that's going to simply be a reflection over the y equals x line. Now if it's too complicated to reflect over the y equals x line, just do one point at a time. What point is this guy right here? That's the coordinate negative 3, 0. So if you switch x and y on negative 3, 0, what's your new coordinate? What's the inverse of negative 3, 0? 0, negative 3. There's your new inverse coordinate. Let's do this coordinate up here. What's that coordinate right there? That's 0, 3. What's the inverse of 0, 3? 3, 0. So put the dot right there, 3, 0. And as you could see, you're going to end up with this line right here. And this is what we call the inverse of g of x. So there it is. We graphed one line, and then we reflected it over the y equals x line. How do we reflect it? All you did was take each coordinate and switch x and y. If I would have done this coordinate right here, this coordinate is negative 1, 2. Well, switch negative 1 and 2, that'll be 2, negative 1. So if you go 2, negative 1, you see how you get to that coordinate right there? So you can take any coordinate you want, just switch the x and the y, you'll end up with this reflection over that y equals x line. That line gets reflected over this y equals x line, and it ends up being that blue line. Here's your original g of x, here's your inverse of g of x. So 1 was easy, 7 and 9 are pretty easy. Just think y equals mx plus b, switch x and y, and you'll get your inverse. And now down here, determine whether each pair of functions are inverses of each other. All you have to do is plug in one function into the other, make sure that the answer is x, and then plug it in the other way around and make sure that it's also equal to x. I don't know, 10 might be a little too easy. Do you guys want to do 10 or you want to pick a different one? What's up?
11.
11. Sure, why not? Let's do 11. Wow, that looks fun. So they're asking us if they are inverses of each other. So how do we know how to check if they're inverses of each other? You plug one into the other. So what do you guys want to do? F of g of x first or g of f of x first? We need to do both. F of g of x. So let's plug in our g of x function into our f of x function. Okay, so my f of x function is really a negative 4 times x plus 1. What am I going to plug in those parentheses? My g of x function. What is my g of x function? It's 1/4 times 1 minus x. Are you with me? Okay, so let's actually work this out. Let's zoom in right here. Let's see what happens. You start with the inside of the parentheses, and even on the inside, we're going to distribute that 1/4 to each of those. So when I go 1/4 times 1, that's 1/4. When I go 1/4 times negative x, that's negative 1/4 x, correct? I still have the parentheses, I still have the negative 4 out here and the plus 1 out here. Next step would be to distribute. Negative 4 times 1/4, that's just a negative 1. Negative 4 times negative 1/4, that's going to be a positive 1x, or just x. And of course, I still have the plus 1. What happens when I combine the negative 1 with the positive 1? What happens? Cancel out. You just end up with x. And that's what we're looking for. Check. When I plug in one function into the other function, if I just get x, if everything else cancels out, I know so far they are inverse functions of each other. But it has to work both ways. I also need to check and make sure that when I plug in my f of x, into my g of x, it also needs to equal x. So let's do this. I want to plug in my f of x right into my g of x. My f of x is going to go right into my g of x function. So let me start by writing the whole g of x function. G of x equals 1/4 parenthesis 1 minus x. But instead of x, I put parenthesis. And what am I plugging in right here? The minus 4x plus 1 is going to go right in there. Minus 4x plus 1. So is there anything to distribute into the parentheses? The minus sign, correct? So when I do distribute that minus sign, minus becomes positive 4x. Minus with the plus becomes a minus 1. And we still have the 1 in the front, we still have the parentheses, we still have the 1/4 out here. Are you with me? And now inside of the parentheses, we have this positive 1 with this negative 1 that we could combine, which eliminate. So what do I end up with? I end up with 1/4 times the inside, which is just 4x. And when I multiply 1/4 times 4x, what do I get? Just x, right? If you want, think of it this way. Put the 4x over 1, multiply the top with the top and the bottom with the bottom. You will end up with 4x over 4. And the 4's are able to cancel, which means x is just your answer. So ladies and gentlemen, that's our second check right there. We know that yes, these guys are inverse functions of each other. Yes, they are. Why? Because this gave me an x and that gave me an x. If I would have ended up with a 5x and a 5x, they are not inverse functions. It has to be nothing but x. And that's about it, guys. I mean, that's probably as hard as it gets. Everything else looks easier. Good luck.